Hi everyone, welcome to a Tess Academy YouTube video. This is part of our GCSE Physics revision lesson series. Today we will run through the atomic number, mass number, isotopes and ions. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements or suggestions to us through the website. Thank you. Firstly, let's run through the atomic number, which is very important in physics and chemistry and is often really crucial for calculation questions. Atomic number is the total number of protons in an element. The number of protons in a nucleus determines which element an atom is. In the periodic table, elements are in order by their atomic number from smaller to larger atomic numbers. The atomic number of a specific element is always the same, so for example, for hydrogen it is always 1. Examples are boron has an atomic number of 5, so it has 5 protons. Sodium has an atomic number of 11, so it has 11 protons. Since all atoms have the same number of protons and electrons as they are completely neutral, the atomic number is also equal to the number of electrons. Therefore, atoms have no overall charge, 0, as the positive charges from the protons and the negative charges from the electrons cancel each other out. So, as you can see in that diagram, the chemical symbol is Na, which represents sodium, and therefore that 11 number over there represents the number of protons. Now let's study mass numbers, which are a very different concept to atomic numbers, but it's important you remember the difference. The mass number is the total number of protons and neutrons in an element. Mass number represents the total number of particles in the nucleus, since the protons and neutrons are all in the nucleus. To find the number of neutrons, you can subtract the atomic number from the mass number. Therefore, the formula would be that the number of neutrons is equal to mass number, subtract atomic number. For example, a sodium atom has a mass number of 23 and an atomic number of 11. Therefore, to find the number of neutrons, you would do 23 subtract 11, which gives you 12. Therefore, there are 12 neutrons in the nucleus of sodium. So, just to clarify, if we look at this chemical symbol here, you've got the atomic symbol, which is Na, standing for sodium. You've got the mass number at the top, which is the bigger number because it's the sum of all the protons and neutrons. And you have the smaller number at the bottom, which is the atomic number, as that only represents the number of all the protons. Isotopes are very important to learn as they come up in many topics, so please make sure to understand this well. Isotopes are atoms from the same element which have the same number of protons but have a different number of neutrons. This means isotopes have a different mass number but the same atomic number, which can be used to determine how many neutrons or protons they have. Isotopes occur naturally. Isotopes have the same chemical properties as neutrons don't have a charge and they still have the same atomic number, so they are still the same element. However, different isotopes have different masses as neutrons do have a mass. The diagram below shows 2 isotopes of beryllium. As you can see, one is beryllium-8 and it has 4 neutrons in the nucleus, and one is beryllium-9 which has 5 neutrons in the nucleus but the same atomic number and the same number of electrons. On to ions. Ions are charged particles produced when an atom loses or gains electrons. Ions from the same element have the same number of protons but a different number of electrons because they lose or gain electrons. When the atom loses an electron, it becomes a positive ion because the electron is negatively charged. An atom can gain electrons as well through chemical reactions. An atom can easily lose electrons from its outer energy level. This can happen if objects rub together, causing electrons to be removed by friction. When electrons absorb EM radiation, it can gain enough energy to leave the atom, and chemical reactions between 2 or more elements or compounds can happen. Ions are more chemically reactive than atoms due to their charge. Ions have the same mass number and atomic number but different charges. This is because the number of protons and the neutrons stays the same, but only electrons can change. So for example, in the diagram, you have a boron atom with 5 electrons and a positive boron ion with 4 electrons, and it's positive as it's lost 1 negative electron. Let's put our understanding to the test and answer a few questions. The first question is an MCQ. Choose the correct box. You can do this independently and check back for an answer after pausing the video. The mass number represents the number of electrons and protons and nucleus, neutrons and electrons, or protons and neutrons. The correct answer is protons and neutrons because remember the mass number is everything that's inside of the nucleus, which are just protons and neutrons. Complete the table. You need to use a periodic table for this, so make sure to have one handy. The correct answers are 17, 25, and 17 because remember the number of protons and electrons are the same and use the definition of a mass number for this question. And now, the last question. Explain why atoms have no overall charge. Make sure to include a thorough and detailed step-by-step to get full marks for this. The answer is that atoms have the same number of protons and electrons, which means the charges cancel each other out, making the atom neutral. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for key stages 1, 2, and 3, along with specially formulated 11+, GCSE and A-level lessons. Further information can be accessed on our website at tessonlineschool.com. And if you would like further resources, advice, and feedback, please contact us on the following numbers. Thank you.